Let's sketch the graph of this rational function. The first step is to factor the numerator and denominator. Well, look at this. These are already fully factored, so we don't need to do anything there. The next thing we can look for are, let's look for x-intercepts. Well, x-intercepts arise where the numerator is equal to 0. Well, what are the only values of x that can make the numerator equal to 0? Well, x equals 0. So the x-intercept is the point 0, 0. Let's go ahead and start sketching the graph right now and start plotting these things as we discover them. So we just discovered the x-intercept was the point 0, 0. There is no other x-intercept because there's nothing else that makes the numerator 0. What about vertical asymptotes? Well, vertical asymptotes arise where the denominator is equal to 0. Well, that happens when x is equal to 1. So I can draw a vertical asymptote through x equals 1. Okay? What about horizontal asymptotes? To find horizontal asymptotes, we ignore all but the highest order terms in the numerator and denominator. Well, we get this expression. Now, if this resulting expression approaches a particular number when x gets large, then we have a horizontal asymptote. But that doesn't happen. This expression simplifies to x. When x gets large, well, that expression gets large. It doesn't approach any particular number. So we do not have a horizontal asymptote. Now, is that the end of the story? Well, in fact, it's not. There is something we can do. Whenever the degree of the numerator is 1 larger than the degree of the denominator, we're going to get what's called a slant asymptote. And we can find that slant asymptote simply by doing the polynomial division that's suggested here. I'm going to divide x minus 1 into x squared. It's always a good idea, I think, to write out this polynomial in its entirety. So let's write out the other terms with the zeros as their coefficients. It's the same thing. And what do I get? A remainder of 1. What does that mean? That means that x squared divided by x minus 1 is equal to the result that I obtained up here, x plus 1 plus 1 over x minus 1. Now, what we should observe is that when x gets large, this expression here gets very small. Because when x gets large, the denominator gets large, and 1 divided by a large number is a small number. So this expression over here gets very small. And so what we see here is that for large values of x, this expression is similar to this expression right here. Well, this is just a line. And I can graph this line. It's a line with slope 1 and y-intercept 1. So that is this line right here. That's the line y equals x plus 1. That is our slant asymptote. Now let's graph this function. So we know that the graph has to go through this point. Now, where does it go from this point? Does it go up or does it go down? We know it needs to approach this vertical asymptote. So it's either going to come up here or go down here. Well, it's either going to be positive or negative. To investigate that, let's just take a number in this interval and plug it in for x. So for instance, plug 1/2 in for x. In the numerator I get a quarter, and the denominator I get negative 1/2. A quarter divided by negative 1/2 is negative. I don't really care what the value is. The fact is I can see it's going to be negative. That means that the graph has to go down. So it has to go into the negative realm here. So we know we have to go like this. Now what happens when x is less than 0? Does the graph go up like this, or does it stay down here? Well, when x is less than 0, the numerator is positive and the denominator is negative. Positive divided by negative is negative, so it must stay down here. Now we know not only does it stay down here, but it has to approach this slant asymptote. So it really has to go like this. Now what does the graph do to the right of our vertical asymptote, x equals 1? There's a couple ways to reason this out. One thing you could do is plug in a number over here and see where you get. So if you plugged in 2 for x, go ahead and plug that in. You'll see that 2 squared is 4, 2 minus 1 is 1, 4 divided by 1 is 4. So we know the height is 4, so we know it's got to be up here, right? Now another thing you can do is you could realize that it's got to have this as an asymptote, right? So then you can ask the question, does it come up from down here and approach the asymptote this way? Or does it approach the asymptote from above? Well, thinking about that a little bit, you realize it's impossible for the graph to come down here, because if it did, it would have another x-intercept. But we concluded the only x-intercept was at 0. So that's impossible. So I know the graph has to be up here. Secondly, we know that the graph has to approach this slant asymptote. So really what happens, if you'll allow me to just fudge this a little bit and move this point down a little bit, even though that's not entirely accurate, I just can't fit it in the graph otherwise. We know the graph has to go like this and approach that slant asymptote up there and approach this vertical asymptote over here. And that is how we can sketch this graph.